Hello, I'm Park, a master student in the Department of Artificial Intelligence at Korea University. In presentation, I will present the key paper of my research. Before explaining the paper, I would first like to introduce the field of open domain question answering. Given the question in the following figure, there will be an answer to the question, and we search for related passages from Wikipedia document to find the hint of the answer. And from some of the searched document, we now perform a wording comprehension. According to Chan's paper blog, retriever used the TF-IDF method in the figure to department to the similarity between the question and the Wikipedia document and determines how often the word is repeated and how often it is used. This retriever is called a space vector retriever. For example, retriever is useful when the bad guy of the question is used as the bad guy keyword is in the passage. Next research conducted is Canton's paper as follows. The feature of the paper is that in the previous study, retriever was not a form of learning but a heuristic method of selecting a document, but in the study as shown in the following figure, retrievers is a structure that optimizes source learning. In the process of learning, the purpose of finding a passage similarity to a question is performed in the form of calculating the similarity source embedding. Therefore, this retriever is called a dense vector retriever, and as a characteristic feature, it is possible to judge that the passage is approximately similar even if there is a word with similar meaning, such as villain, even if the clear keyword of bad guy does not exist in the passage. Therefore, since dense retriever is a technique that utilizes bird-predicted embedding, it has improved over the previous TF-IDF-based heuristic retriever. I'm going to introduce this paper dense passage retriever for open domain question answering, published in EMNLP. In this paper, the pre-training based methodology is pointed out, but first pre-training itself is very burdensome in the calculation. Second, it is unclear whether a general sentence can replace the question. In addition, in the case of ICT pre-training, in order to devise a pre-training for suitable for question answering, a sentence is arbitrarily imported from the passage and acts as a free pseudo question, and it is a pre-training form if a similar passage is retrieved. However, although it is called a pre-pseudo question early, it is definitely a sentence, not a question, but it is not clear because this method of learning is not a form of question. Finally, in previous papers, when pre-training and performing fine-tuning, the passage encoder is frozen and only the question encoders and the reader model are updated through fine-tuning. The passage encoder pointed out that it is not an optimal solution for QA tasks because it is not updated. Therefore, the main problem to be addressed in this paper is to train a better dense embedding model, but to make a good model with only a question passage where without additional prior learning. The proposed method focuses on improving retrieval performance in performing open domain A. In addition, given m passages in training retrievers, it aims to map information on each passage to a low-dimensional space. However, since the passage targets Wikipedia document, the m is very large. In the experiment, it was reported as 21 million passages. After that, the passage can be mapped to a low-dimensional space, and the top K passages associated with the question can be effectively extracted from it. In this paper, K is generally placed between 20 and 100. Retrieval is expressed by the figure below. There are birth embeddings from the question, very many passage embeddings, that is 21 million weight embeddings. After that, the top K passage is extracted by calculating the embedding and the similarity of the question. Now I will explain inference and training. And inference first. After training in the inference step, since the parameters of the model are fixed, a library space for calculating the similarity between vectors is used, and the embedding vector of the passage encoder is calculated in advance. Thereafter, when a new question enters the input, it has a form of quickly returning the related passage. Next, I will explain the training step. The purpose of training is to build a vector space located in a nearby space between passages related to the question. In the first equation, the data indicate that there are negative passages that are not related to the passage related to a question. After that, as shown in the second equation, the training is conducted so that the negative log likelihood is optimized and the similarity of the question and the positive passage is located close. At this time, looking at the equation in the previous slide, I have debated about how to set the negative passage for the question. So I will explain positive and negative passages, the first training technique introduced in the paper. The range of selecting a negative example for a question from 21 million Wikipedia documents is too wide. So you can create an encoder that has an excellent, careful choice of negative examples, and there are three ways to choose. First, random is to randomly extract a passage from the corpus, and the second, because BM25 is a negative sample, it does not include a correct answer, but it means a passage where the tokens corresponding to the question overlap the most. This means that is a sample that is difficult to distinguish to the extent. Finally, Gould used the positive passage of another question as the negative passage of the question. The second training technique is in batch negatives. There is a positive passage corresponding to one question and another negative question, which can be expressed as a mini batches as shown in the following left figure. For one question, I also used negative samples in another mini batch. In middle figure is if there is a question embedding consisting of 5 mini batches and the embedding sizes are 3. The passage embedding of the same size corresponding to each question is transpose. Multiplying these two matrix results in a B by B matrix. This means that the first question and the first positive passage are shown in yellow and calculated like each color. The diagonal line of the matrix response represent the similarity with the positive passage for each question, and the colorless cell represent the similarity with the negative passage for each question. So both positive and negative similarities can be utilized in one matrix. It is simple and has the advantage of being memory experience. The following shows the result of the experiment in this paper. Main setting use the method I introduced earlier, and I will explain them with the table below. Here, retrieval accuracy represents the probability of picking a passage with the correct answer when a question is given. In the table, experiments were conducted on top 20 and top 100, and it is divided into when heuristic-based retrieval is used and when DPR is used, showing in BM25. And this time, it can be seen that the performance gap is greater when it is 20 than 100. Also, on the SQUAD dataset, we can see that the heuristic technique performs well because biases exist and use a small amount of Wikipedia document because the annotator writes questions after seeing the passage on the dataset itself, and the part of multi is the result of combining our data except SQUAD when running, and BM25 plus DPR is the linear combination of each retrieval score. Looking at the result in the table, it can be seen that the overall performance was excellent when using DPR. The following is an experiment on sample efficiency in this paper, and the blue line at the bottom of the figure is the result of the heuristic-based retrieval. In the table, it can be seen that even if only 1,000 training datasets were used in the DPR, the performance of BM25 was exceeded, and the accuracy increased proportionally as the data is increased. The following is a table showing the effect of in-batch negative training. To explain step by step, first of all, it can be seen that the top left, if K20 or more, there is no significant effect on the negative passage selection method. In the next middle block, if you look at the red frame first, you can see that the in-batch negative method is effective in improving performance. Next, if you look at the blue frame, you can see that the accuracy improves as the number of negative samples increase. In the last bottom block, it is an experiment on the method of adding one or two BM25 based hard negative passages in the gold method. Here the hard negative passage refers to a passage that is similar to the previous negative passage selection method but does not include a correct answer. Therefore, using the hard negative passage lead to performance improvement, and it can be seen that using 2 does not have a significant difference in performance from using 1. Finally, the previous focus was on retrieval, but the following experimental table show the result for question answer. Looking at the table, high retrieval accuracy also shows good result in QA result, which is typically a downstream task. In addition, both ORQA, REALM had additional pre-training tasks, whereas ODQA using DPR retriever in this paper derive better performance in NQ and TBQA using only QP fair. However, there are limitations to the key paper. First, lack of documents level inference. The model struggles with question recalling information spread across an entire document, lacking full context or needs. Second, dataset bias by QA benchmark mostly focus on localized question, potentially overestimating model performance on documents level inference text. Third, high computational cost, dense vector presentations includes computational demands, especially with large document collections. Therefore, I do like to proceed with the research to solve this point. I'm currently working on it, conducting research focused on 4 things. First, it integrates information from multiple sections within a document to consider to the full context of a lengthy text. Second, by combining paragraph level and document level encoding, it enhances document inference capabilities. Third, it is trained on diverse dataset, including questions that require complex reasoning. Finally, multitask learning improves its ability to generalize across various types of questions. Thank you for listening to my presentation. Thank you.